I will start off basically with Y2K and what that has to do with the Raspberry Pi. So, I mean, really talking about the Y2K bug is perhaps a strange way to talk to begin to talk about the Raspberry Pi. But let's rewind a bit back to the year 2000 and think maybe about how much has changed in the last 20 years. When the news of the Y2K bug hit mainstream media, most of us heard about it on news channels and not from social media that didn't exist back then yet. So it was quite interesting to see how out of proportion this issue was made to be. But, you know, I guess there was always that element of uncertainty and fear. You know, would my bank account show a balance of 0 the next day, or would our nuclear power plants melt down? It's quite interesting because a survey conducted at that year showed that half of the households in America already had a computer with internet access. Obviously, nothing serious ever happened with the Y2K bug, but I think everybody in the world must have heard about the story, as it could have directed them directly. It could have affected them directly or indirectly. This bug had been fixed many years prior to this date anyway. So as the year went on, nothing bad really happened, but probably most of the population on Earth learned about the computer and how software, you know, can have effect on our lives. In my opinion, it probably had a positive impact for people who didn't own a computer yet. As the years went by, basically, and technology improved, access to computers got a lot easier, and I think that positive feeling of, you know, Y2K not ruining our lives must have resided pretty well with us. So I think over the next decade, the world, you know, went from Nokia 3310 to an iPhone 3GS, similar form factor, but processors that packed in 100 times more processing power. Went from monochrome screens, no internet, hard to press little buttons, to full color touch screens and constantly connected to the internet just within 10 years. Both Intel and AMD passed the 1 gigahertz CPU barrier around that in 2000, where a lot of people in the computer industry actually thought that that would never happen. So that was quite an achievement. So as the decade passed, around 2010, a British company actually started to advertise a credit card sized computer that can run full Linux distro, has many general purpose pins, and costs only £35. So I'm quoting here, the Raspberry Pi Foundation is a UK-based charity that works to put the power of computing and digital making into the hands of people all over the world. So I'll take this chapter just a moment to introduce myself, a little bit of a bio of myself. So hello, my name is Piotr Kula, and I have a Raspberry Pi addiction. Thank you for joining us tonight. So Jan did ask me, you know, am I Polish? Yes, I am. I was born in South Africa. My parents were Polish. So I have a dual citizenship, and about 25 years later, I actually decided that England was going to be my new home. When Jan asked me to write my bio up for this talk, I mentioned that I was practically born with a keyboard, which looking back, I thought, okay, that's a bit strange, but how did I actually come up with that? I was trying to think back as far as possible as I could. And, you know, I was born in 1982, so that's quite a bit back. And really, all I could remember in my mind is clickety-clack of a keyboard. Well, now I know that's the IBM Model F keyboard as shown on this screen over here. Fantastic keyboard, virtually indestructible. You can still buy it today and it still works, unlike many other keyboards. So yeah, the IBM XT, one of the first PC computers released in about 1983. I mean, that was a computer targeted for businesses. It was very expensive at that time. My father worked as an electrical engineer for the gold mines, and around 1985, I think he managed to purchase it at quite a reduced price. And that was his and my first computer ever. I think I was about 5 years old about then. So I do recall my parents talking about this a bit, where I started taking apart the machine and asking my father about all the components inside of it. He still worked at the gold mines as an engineer, so he had access to purchase components. And I remember our first RAM upgrade was 128 kilobytes to 256 kilobytes, which consisted of like these 8-pin chips, 9 of them that you had to plug into the motherboard very carefully, not bending pins. But later on, that actual, I think the IBM XT 1985 was released with 640 kilobytes of RAM installed as standard. I mean, as the years passed, I mean, I upgraded to a VGA color monitor and remember dial-up BBS. Yes, that's still pretty far away from actually having internet as we know it today. I finished school, went to university, worked in IT, fixing computers and for people, doing some construction at the same time to pay off schools and, you know, just try to get forward so that I could move to England. And that's where I decided to start a few of my own businesses around electronics development, data recovery, software contracting. I tried a few things, just general IT consultations for business. And in that time, I managed to write 2 books about the Raspberry Pi. And I think I fixed about 314,159 bugs in various programming languages. So yeah, and in the last 5 years, really, I've been a full-time technical lead for a fantastic Norwegian company that deal with health and safety. And I get to work on solving a lot of problems across various different platforms, and I enjoy doing that, work with a fantastic bunch of people. So I'll just quickly go over the format of this talk. The slides and the script will be made available, which contain extra links and references to everything that I'll be mentioning. And I believe if there's any questions, we'll do that towards the end of the meeting. So I'll just start off with a bit of history about the Raspberry Pi. Eben Upton, who's the inventor of the Raspberry Pi, he set up the Raspberry Pi Foundation and managed to sell over 30 million Pis in a decade, so between 2012 and 2022. To put that into perspective, that is the 3rd best-selling general purpose computer just after the Mac and the PC. So that's quite an achievement. And obviously that wasn't easy, but Eben sought to solve the problem of creating a powerful computer for beginners to learn how to program and have realistic prices for students. So it was all about solving a huge gap in the education around computers, mainly due to high prices of hardware. Even schools struggles to afford to buy computers, you know, for their students. So while he was working for Broadcom, a large microchip manufacturer, Eben created his first prototype board around 2006. So this is what we can see on screen now. A bunch of, I think there's an Atmel in there. So these are microcontrollers that he was tinkering around with. And he did this mainly during his weekends for the next 6 years, essentially trying to come up with the first prototype Pi. Well, the first Pi that was released, so Raspberry Pi 1 Model B in 2012. I couldn't find a source, but I believe there was something like 100,000 units that went on sale, and they sold out within days, if not hours. And that made a massive uproar. So that is when I first about the computer. that cost £35 and basically sold out in a flash. So, even set out to solve the problem for young technology enthusiasts, essentially, so for students and people wanting to learn about computers. But unknowingly, he actually tapped into a desperate market of all technology enthusiasts, and that actually made 4/5 of Pi sales today. So Eben's experience working at Broadcom allowed him to create a custom processor and fabric an extremely high quality board that just appealed to everybody in the tech sector. And this is really one of the most attractive things about the Pi, that it provides ultimate control to its users. It is well designed, handles a wide variety of inputs and outputs, supports a wide range of operating system and programming languages. So the appeal for this kind of single board computer just blew up everywhere. So I'll talk about a little bit about IoT on the sidelines of Raspberry Pi. The actual idea of Internet of Things was actually around since the 70s, but the term IoT was actually first coined in the year 2000, and it did not really gain a lot of momentum until 2010. So back in 2000 again, if you knew how to write some basic software and understand how to connect a serial programmer, you could create your own smart device quite easily. The hobbyist embedded developer really had two popular ways to build things, by either using a pickaxe, it's top right, or I think some people call this a pixie, and an Atmel's Atmega, which is on the bottom left. So two competing companies. The pickaxe was actually available from '99, and the Atmel became really popular with a single board computer known as the Arduino in around 2005. But by today's standards, calling any of these boards a single board computer will probably get a lot of criticism. Even though these paradigms are available and extremely popular choices, they still have a difficult learning curve. Neither of them had an operating system, and you had to learn their programming languages separately. So Pickaxe kind of had the same idea as Eben from Raspberry Pi. They wanted to make a simple to learn and cheap to buy microcontroller for educational purposes. So they used a programming language called BASIC, which was available in MS-DOS 2.0 since I believe 82, and was quite popular during those years. So it was and easy to learn. Arduino seems to be based on C++. If you've ever used it, and you could compare, the syntax looks quite similar, but it was eventually called the Arduino programming language because it was really more a set of libraries that you could just work around with some scripting that resembled C++ syntax. So the nice thing about the Pickaxe is that you could just buy a cheap IC. It could be $1, not even. I think these ones, yeah, like 50 cents or something, the little small ones. So really, really cheap. You connect a few wires to it. Everything is built in. Little crystal to run the clock. It's all there. You just create wires, put it into a breadboard, and but yeah, it did require more hands-on evolve, where the Arduino single board computer resemble more of what we know as a Raspberry Pi today, but lacked a lot of input-output capabilities. These microcontrollers ran at 4 or 8 to 16 megahertz, super reliable, cheap, and once you learn, really easy to program and build upon. But still, in the year 2010, if you're a hobbyist embedded developer, you had still a serious problem to deal with. I mean, your personal computer, your phone, your television, had hundreds, if not thousands, times more CPU power than and were all connected to the internet wirelessly. And even at that time, trying to get Ethernet to work on a microcontroller was quite a challenge. You could buy an off-the-shelf Wi-Fi or Ethernet SBC, but you're probably looking at $50 to $200 for an Atmel-based one or any other competing similar product. And the reason was that you could buy a used Super Micro ATX motherboard with a processor, LAN, Wi-Fi hard drive, lot of storage for a lot less than that. So it was quite challenging at that point to get a small device with a lot of power and flexibility. So as 2012 comes along and the first Raspberry Pis get sold, I think I remember that every kind of hobbyist forum just got flooded with a talk about the Pi, a 35-pound computer that can do everything an Arduino, a Pixac can do. It has a 1080p HDMI output, hardware encoding for DVD type streaming, supports proper operating systems like Linux or RISC OS, has a 100 megabits LAN on it, 512 gigs RAM, and packed an overclockable 700 megahertz CPU. I think you can overclock it to 1 gigahertz, the original Pi, with a bit of tinkering. So that was very impressive for that price mark. And it had 40 general purpose IO pins, including all the standard hardware, I2C, SPI, serial UART, and a MIPI CSI port for displays or cameras that you could attach to it. And the nice thing is that the support was built directly into the operating system known as Raspbian, released at that time, and it supported Python on the day, and it supported Python. Python supported everything, all the hardware that came with a Raspberry Pi on the day of the release. But anyway, I had to double check, my calendar if this wasn't an April Fool's joke, because I dug around a bit more and eventually landed on DigiKey's website and saw the Raspberry Pi, one listed for 35 pounds, and yep, bought 2 of them. And yeah, they arrived and I was completely blown away. So that explains why 4/5 of purchasers are hobbyists. At that time, to buy a decent speed microcontroller, around maybe 120 hertz or 240 hertz with a 10 megabit built on LAN, I mean, goes up $50, $100 or more. So this was an extremely exciting alternative. I believe the Pi was released at the perfect time and brought together everybody that was interested in technology in some way. So in a way, I think Eben achieved more than just getting students to learn, but he got everybody that had an idea, whether it was software developers, robotics engineers, production line managers, CNC machine operators, or just even the parent and their child that want to learn about something. Yeah, and computers are everywhere. Our children today have already passed that learning curve of how to use a computer. It's pretty natural to them now how to use it. But so it's not rare to find a 5-year-old asking if they can run Minecraft server on the Raspberry Pi. That's quite cool to hear about. So, but maybe you're interested in recording something from Mother Nature by means of a time-lapse camera that could be built in a weekend and could record footage over 12 months or longer. Just made things a lot simpler for everybody and quite interesting. So it is kind of the perfect storm. I do have a heavy Microsoft background and only started learning about Linux more and more when I bought the Raspberry Pi. So looking back at all the events since 2000, I could say the timing of everything seems to be perfect. By by 2012, the hobbyist Linux community was thriving. Open source software was well established and hardened. It was used everywhere and trusted. So the Windows guys were desperate at this time because, you know, Windows Phone was what, $1 billion flop, and Windows Embedded pretty much never made it to mainstream usage. So yeah, we were still stuck with 150-pound Intel Atom machines as the best thing for us to, you know, run C# or Win32-bit applications on. Sorry, wrong slide there. So I believe the success of, you know, ARM and Raspberry Pi really hit a bad nerve with Ballmer, who was a CEO at Microsoft at the time. But luckily, Satya Nadella set out a bold plan and announced Microsoft Heart Linux. So in between 2012 and 16, .NET developers had probably seen several releases of .NET within 1 year, which was highly unusual, because usually a .NET release took about 2 to 3 years. Windows 10 announced Windows Subsystem for Linux, which basically means you could run Linux inside Windows without a virtual machine or dual boot. So you may wonder why does this seem important? But essentially what was happening is that Microsoft wanted .NET to run everywhere. And today, I can confirm that's achieved, and this and writing C# for the Raspberry Pi in Linux is just as easy as writing Python for the Pi. And it goes the other way, where everything for Linux now runs on Windows as well. So we've just made one massive community, essentially. And this is good for everyone. It means that you don't really have to worry about what programming language to pick for a career nowadays. As long as you can learn the logical approach of whatever language or operating system you like, your experience will be valuable both in the Linux and Microsoft world or paradigms. Talking about cheap IoT nowadays, because that's why we need a Raspberry Pi to control all our little other computers. So I deliberately didn't dive into details about Arduino or Pickaxe, because in 2014, a low-cost Wi-Fi microcontroller started to become very popular in the Western world. And this chip is known as the ESP8266. So it's the one here that says AI Cloud inside. And it's a bit blown up here, but that's about the size of your thumbnail. And it's a really good chip because it's a 32-bit microcontroller. And despite this doesn't have it broken out, it does have 17 general purpose IOs, an I2C, an SPI, a UART, and an analog to digital converter. And it ran at 80 or 160 megahertz. But the crucial thing was it had Wi-Fi built into it. So we had this tiny device. And if you looked around for long enough, you could probably buy like 10 of these for $15 shipped from China. So this hands down beat any other microcontroller in all aspects, namely that reprogramming it was so easy that you could just use your Arduino or BASIC if you wanted to. Eventually it became so popular that there are about 20 different platforms and languages that run on this microcontroller. There's one really easy and extremely popular SDK that runs on the ESP, and it's called Tasmota. It has an extremely easy programming process, but it really wins everyone over with its web UI. So you can configure pins and actions through a normal browser without having to program it. You can also get information displayed on the home page for whatever you have configured. So if you've added a button to a pin, that button will show up on your little dashboard for running off of this device. So the ESP hosts everything for you. Another good SDK, which I just personally use, is the ESP Home. It's also quite easy to configure, but you have to pre-configure everything, flash it off, and then you can't really change it dynamically. But either way, both cases, this lets you run the device 24/7, 365 days of the year without having to log into it again. So I think in the space of 4 years, from 2012, I probably went from having 30 projects in my mind with maybe 2 or 3 completed projects, and then getting a Raspberry Pi, a few ESP devices, and then having more completed projects than actually I could imagine doing in the last decade before that. So yeah, the learning curve, the price reduction of the hardware, you know, falling so much, that was true. You could easily make an IoT sensor every weekend with minimal spare time and have it for years to come. So yeah, I think that's quite a lot to take in. So as I mentioned, I will share all these links, and I think it's just at this stage we talked about these various aspects that you know, you may be wondering where do you even start. So it is a fact that you know, the word Pi was used to describe that this board was built for using Python. So if you'd like to pick up a new language or learn how to code, this is probably the best place to start, is Raspberry Pi org.learn. The desktop comes preloaded with software, also called Scratch, that is mainly built to teach children about code logic. But it's a visual code builder, which you can actually make pretty good games and software with. So it's really interesting to look into that. The Raspberry Pi website is also filled with, you know, resources for teachers and learners alike. It has hundreds of projects and ideas, subscriptions to magazines, countless hours of tutorials, and online clubs that you could join. If you'd like to maybe start venturing out a little bit more to the open world of hobbyist engineering, I would recommend looking at Raspberry Pi Stack Exchange, which has a lot of nice ideas and solutions regarding things around Raspberry. You could search around that. So there's Raspberry Pi, Electronic Stack Exchange, and Stack Overflow. You probably, you know, I visited these lots of times, professionally and as a hobby. It's fantastic sites in terms of information. And yeah, I mean, it would be a shame if I did not mention my book. Although it was published in, you know, 2016, I did at that time deliberately try to make it as timeless as possible, because I knew how fast technology scenes move on. So I knew the OS and the hardware will have moved on, which it has, quite pretty, actually faster than I thought it would have had. But it is an easy starting point, and gets to more advanced topics as you progress through the book. So it does mainly focus around running a Raspberry Pi as a server without any graphical interface, so working on the command line primarily. And I think about the chapters are a bit more like a recipe book, where you can find something that you need to do and you can quickly follow the steps. But maybe if you fancy trying something fresh, then you could just pick a random page and install something that you've never tried before. There's a link there to the publisher directly for my book. There is one last person I'd like to reference to, and if you do fancy doing some hardcore Linux ago, you should visit Jeff Geerling's website. He has a YouTube channel. He's another Raspberry Pi addict, basically, and he does some fantastic work. He puts a lot of work into documentation and testing, mainly what can run on a Compute Module 4. and the PCI Express bus. So through that link, you could get to his Twitter, his YouTube, and all the types of graphics cards and PCI Express things that he's been trying to run on this compute module. But I do have a link about Home Assistant here. I'll talk about that as well in the slides coming on, and a link back to Test Motor just as a reference to the previous slide and slides coming up. So yeah, what is Home Assistant? So Home Assistant was released in 2013. I don't think it really became popular until 2017, when it was released as an operating system to make it run on SBCs like a Raspberry Pi. So Home Assistant is the missing piece of the puzzle around bringing down the learning curve for managing IoT smart devices and home automation. And there is really no sense in trying to write your own software to manage your devices. It's not easy on your own. So Home Assistant is designed to be the central control system for your smart home devices, your own IoT devices like Tasmota or ESP Home, your own software that you write and can integrate into Home Assistant, and maybe the things you buy from retailers like Philips Hue or doorbells. It all integrates into there, and even things that you maybe hacked and converted to something else, flashed it with a different firmware. So it's a fantastic scene of you can find out about new hardware, new things, just by browsing through all the integrations that are supported there. I mean, it does have a slight learning curve, just because it is new. You have to learn how to navigate around it. But in the recent year, I think it's been redesigned to make it more intuitive to use, and it's all controlled by a web UI. It has native apps for iOS, Google, and Windows, and the best part is that it runs locally within your network, so you don't have to worry about external providers like Amazon and Google, but it will integrate with them if you want to. So yeah, Home Assistant still has to call out to those vendors if that's okay for you, but I think you you can stay fully local if you wanted to. There are two virtual assistants called Almond and Genie. They were developed at Stanford University, so you could just go and build your own smart speaker and not use any of the mainstream apps. So yes, clash of the standards. With the amount of smart home devices, the boom of home automation, you can buy things from IKEA, Walmart, Tesco, AliExpress, all branded, by these massive corporations and companies. They all have their own pros and cons, and they try to compete with like Samsung or Sonos, Philips, etc. So I guess with all the competition and the 20 years prior of hobbyists, engineers trying to get the smart devices online, we now have a new problem to deal with. And really, before the time of the ESP, where we could just have Wi-Fi on a cheap microcontroller, there was a divide of opinion on the easiest and cheapest way to get wired or wireless communication to your microcontroller. So people were using either off-the-shelf FM transmitters or transceivers, 433, 800 megahertz, 1.2 gigahertz transmitters. Maybe you didn't care about that. You just attached the GSM module or a phone and used the GPRS protocol because you could afford to do that, and you just needed to, really. So alongside of that homebrew enthusiast. You had large corporations like Texas Instruments, then also offering Zigbee for low-powered devices, which ran at 2.4 gigahertz and gave you the ability, to select the power save mode or full speed data transmission, and use the mesh protocol, so you could extend your network without adding routers or access points in between. Then we also had Z-Wave or Z-Wave, which promised the same kind of thing as Zigbee, but was just forged by another alliance. And of course, we can't forget about Bluetooth and all of its protocols and revisions over the years. Whether it's useful or not is really up to you. But the great news is that Home Assistant supports all of these, as long as you've got the required hardware, which is usually just the access hub for either one of these protocols. But it doesn't mean that you should use all of them. So no, I think it's actually quite a bad idea, and you could end up crippling your normal, network for daily activities, because all of these protocols, except LoRa, runs on 2.4 gigahertz. So it's quite important to choose and try and understand what you want to achieve before, just going out on a shopping spree and buying everything and trying to connect it up to Home Assistant. Zigbee is great for low power devices, buttons that use a coin battery cell and don't need to be awake the whole time. For example, I love the IKEA Zigbee dimmer remotes, but you need that extra hardware and will probably interfere more with your normal 2.4 gig Wi-Fi than it's actually worth. So, but yeah, Wi-Fi on the other hand, the more devices you add to your 2.4 gigahertz does kind of cause the same crippling effect to your bandwidth, as more devices have to chat on the same frequency. So this could be something like the Nest doorbell that runs off Wi-Fi on the battery. But yeah. So really the truth is, if you want to start with smart home gear, you probably need to say goodbye to your 2.4 gigahertz Wi-Fi and upgrading to 5 gigahertz for your entertainment or work purposes. Okay, sorry, I missed the slide there. So I'll just talk about Matter protocol quickly. This is a new protocol, yet again, created by powerhouses like Google, Amazon, Samsung, and Apple, which kind of realized the problem with the protocol that I mentioned earlier. But yeah, their main concern was obviously from the sales point of view, where consumers were confused of, will this product work with that product? Will my Nest integrate with my doorbell? And they were trying to figure out a protocol that would allow all the smart devices from different ecosystems to communicate with each other. And the one nice thing of that is the protocol doesn't have to reach out to the cloud, so everything can run locally. And obviously, Home Assistant will leverage that. It actually makes it a lot easier to then communicate with devices that implement Matter. So this is still something brand new, I've not used it myself, but if you do think about purchasing new devices, probably worth looking out for Matter, and whether, or if you do have anything, if you can upgrade to Matter to make things a little bit easier for yourself. So I just thought I'll quickly go over how easy it is to program an ESP with Tasmota. Yep. So Tasmota can be programmed onto various devices that contain an ESP microcontroller. All you need is a USB to serial adapter, and the website really has detailed step-by-step guide to program this. So you don't even have to install separate software. All it takes is connecting your ground wire, your VCC, which is 3.3 volts, and then crossing your transmit and receive between the two devices. So this could be something like a on-off switch that you want to hack and reprogram. Here's an image of ESP8285, which is a predecessor of the 8266. And this is more of a recent module on the right, ESP12, which is a Wi-Fi certified ESP module. Only one thing that you have to do is what's going on there? Some updates. So if you get everything plugged into your USB and powered on, go to the Tasmota web installer. Kind of looks like this. It's just a website. Select the Tasmota firmware, make sure that it's picked up on your USB through the tool that asks you to, the extension required to install in your browser. And then you're basically done there. You've flashed your device. It does sound quite simple, but you probably might run into trouble. So that's why I shared a link, and they've got a really good guide on how to do it on the website. And yeah, Tasmota template. This is what is probably the most appealing to home automation power users. Once you've flashed your device with Tasmota, you can then dynamically reconfigure it using it through the website with these templates. So you can select what goes under each GPIO, whether it's a button or a pre-configured component, PWM or LED. And as you can see on the little screenshot on the left, that is actually what it would look on your mobile phone. So you'd have like a little slider for dark, a toggle to, for, you know, turning switches on and off. This has like a little power, I think it has attached a power consumption meter. So yeah, I think the question is really, what can you build with these? And you know, the answer is anything you want. ESPs can run off a battery if you want, if you can configure it into a deep sleep mode. That will just turn on in a short interval. But I think ideally you want to run one of these in the mains USB charger and keep it always running. So we could take a scenario like you want to monitor a room's temperature. Then you could buy a Zigbee device, but that would only wake up every hour. But maybe if you want something more granular, this could, you know, record the temperature and send it over to Home Assistant every second. And this could be useful for a number of reasons, you know, whatever you need that for. It could be humidity, it could be, you know, CO2 in the air, or even dust particles if you've got a sensor for that. So Home Assistant offers a built-in time series database, and all of this data can be collected for historical analysis just out of the box. Once you configure Home Assistant, it will pick up on any new devices on your network and almost automatically configure it. You just have to add it onto a dashboard. It's always collecting that data, whether it's on your dashboard or not. So you can always access that. So it's quite nice. But yeah, you probably would want something to happen if a temperature, you know, goes over or under the threshold. And on that same ESP, you could just later on maybe add a wire for a relay, perhaps turn on a fan or make some lights flash or close your automated blinds. You just come back to this web interface and reconfigure what's happening under your pins, and automatically Home Assistant will pick up on that change. So it's a extremely nice integration progress. So there's a lot of templates already available online, and there's a lot of websites that you could search for on how to maybe convert existing hardware that you've purchased into Tasmota. It just makes it a lot nicer to integrate with your Home Assistant. So on here we've got a brand new shiny board. It's called the Home Assistant Yellow, with a compute module on it that plugs in. It shows an SSD, which is NVMe actually, that does work with the latest Raspberry Pi OS. I did pre-order one of these. I'm still waiting for this to come. And I'm going to have my Home Assistant run on this, control all the smart things in my house. It's really nice because you've got a little Zigbee device pre-installed, power over Ethernet, a bit of USB, mains powered, and essentially it comes in a nice case that you can just put away and it will just run for you. So I thought maybe I'd go over the installation process. Sorry, I've just not really been keeping track of time. Are we still okay with the time?
A couple more minutes, be good. How much more time do you think you need?
About 10 minutes.
Okay, that's fine.
Yeah.
Okay.
Yeah, 10 minutes is good.
Yeah, just go over how we could configure Home Assistant on your Raspberry Pi. So yeah, the Home Assistant can be run on any computer really, in a virtual machine, whether it's Windows, Mac, or Linux. And you can follow the guide from Raspberry Pi on how to do that. But you can download this tool called the Raspberry Pi Imager from the Raspberry Pi website. And really for long-term usage, if you want to run your Pi always on, it's highly recommended to attach a USB storage like a SSD or something. It doesn't have to be the best and the highest performing one. It could even be a secondhand 120 or 250 gig storage device attached to a USB to SATA converter. I've got a few running like that, and it works really, really well. The SD card, if you just keep it running, it will basically deteriorate over a few months and just corrupt and cause you a lot of nightmares. So it's as simple as connecting your USB SSD to your machine, downloading a Raspberry Pi Imager, selecting other specific purpose OS, and Home Assistant is listed under there, and it will download it and write it to your USB SSD drive. So if you've not already upgraded your Raspberry Pi's firmware to allow USB boot, then from the same utility you can use a different SD card and go under bootloader and select USB boot. You essentially put that SD card into your Raspberry Pi. It will do a lot of green little flashy lights, and if you've got the screen connected, you'll see a green screen come up, and then you can plug your Home Assistant, power it off, plug your Home Assistant in, and it'll boot up. So once it's booting up, you go to Home Assistant 8123 URL. This should pick up from through your router's DNS, but if it doesn't, then you can plug your HDMI screen in and find the IP address or log into your router and see what the IP address is. But I found that this generally works pretty well. And then you can, through your normal computer, start configuring Home Assistant through its setup process there. So just wanted to show you more or less what like the dashboards look like. I mean, I personally see the Home Assistant software, you know, all the hard work that was put into making the customizable dashboard UIs. This was always the biggest problem for myself, you know. I could make a device, I could write the software, do all the integrations, but when I tried to do a dashboard or a front end, it just never really worked out. I tried different approaches. Some, you know, they worked, but they were ugly, and others were pretty, but they were complicated to work with. And yeah, they was just landed up being forgotten about. Home Assistant is very modular. So I treat it as a front end because it's got your time series database in it. It's got all the integrations for your home automation, but it actually allows you, it actually runs Docker. So you can install anything you would like in Docker to collect all sorts of data. You can install like Visual Studio Code to do your editing of files. There's, I think, Grafana dashboards. They've got some native integration for energy dashboards, so you don't have to write your own dashboards. This has already all been done for you. It's a highly sought after feature. And yeah, I mean, I think the Home Assistant is a great front end for your Raspberry Pi server, essentially, while allowing you to build or add extra software in and customize it and let it run the way you'd like to have your server running. Yeah, so that is that's the end of my presentation. Thank you very much.